So we just saw an example where the center of mass of an object, an elongated object, can be calculated where that object had an even density or constant density throughout its whole volume. But in this case, we can take the same ruler, and if instead of having an even density of 1 gram per centimeter squared, we actually had a density for the first 4 centimeters 1 by 1 centimeter units of 2 grams. Those are the red chunks at the beginning. And the last 8 1 centimeter by 1 centimeter chunks are 0.5 grams. Then we can calculate the center of mass in the x direction for this new ruler. Your intuition should tell you that, much like balancing a seesaw, that the pivot point or the balance point, which is the exact location of the center of mass, should be closer to the red side and farther away from the purple side. But that intuition doesn't quite tell us exactly where it is, and that's why we need to do the calculation. We do the same calculation that we did before. We put the numerator to be each mass of each chunk times its location. So again, the first 4 chunks will each have 2 gram masses, and they're located at 0.5, 1.5, 2.5, and 3.5. The next set of chunks will all have a mass of 1 gram, and then the final 8 chunks will have a mass of 0.5 grams, the last one being centered at 27.5 centimeters. And you can just do that straight arithmetic. The denominator is just the sum of all the masses, so the first 4 masses have 2 grams, the last 8 masses have 0.5 grams, and the middle masses that are all green have 1 gram. You can just count them up and multiply that all together. You can do that calculation and find that the top has it's 304 grams centimeters, and the denominator is 28 grams total. And then when you do this, you can find that the center of mass is now at 10.9 or almost 11 centimeters, which is located here. And so this is, as our intuition told us, it shifted towards the red side of this ruler. It's no longer right at 14 centimeters, which is right in the middle, and that's what we would expect. So in all these examples, we just calculated the center of mass in 1 dimension, but you can do the exact same thing in x, y, and in z. So I'm giving you the equation for y, but the equation for z is the same as well. And this, as always in this class, this is a recurring theme in the class. X, y, and z are not intermingles. They all act separately, and each has its own center of mass location. And so that center of mass has a position in 3 dimensions. And so you can calculate them all separately and have the position for the center of mass or the balance point.